will be years before that project becomes a reality. If it goes as planned, the journey to Proxima b will take about 20.
Quite a few instances over the years, and it doesn't surprise me.
It's only a tiny pinprick in the sky, barely a speck, a whisper in the dark. But now, for the first time in history, we can actually see it. Proxima b. Humanity has just caught its first clear visual glimpse of a potentially habitable planet orbiting another star, and it's not a distant fantasy anymore. This isn't just a blurry detection in data charts or a faint spectral wobble. This time, we have a true image, refined through thermal scans, infrared frequencies, and some of the most advanced instruments ever put into orbit. And it changes everything. Because this isn't a gas giant with swirling clouds. It's rocky, compact, about the same size as Earth. It orbits within the narrow sliver around its red dwarf star that scientists call the habitable zone. And now, it's no longer just a theory on paper. It's a world, a real one. The James Webb Space Telescope has been breaking barriers ever since it launched, but this observation? It's a landmark. Tucked just over 4.2 light-years away in the Alpha Centauri system, Proxima b has always been a subject of speculation. Discovered in 2016 through the subtle tug it exerts on its star, we've only had models and simulations until now. Webb has done the impossible. It has isolated this world's faint infrared heat signature from the overwhelming glare of its parent star. That's like detecting a candle next to a stadium spotlight from across a continent. And the image it produced? Not just a round, not just a blur. It shows variation, surface features, possibly topographical highs and lows, even temperature gradients, the suggestion of clouds, maybe even circulation. And somewhere in all that, the whisper of an atmosphere. That's the part that caught everyone off guard. We've long feared that Proxima b might be scorched by its flaring, temperamental star. Red dwarfs, especially ones like Proxima Centauri, are known for violent outbursts, radiation storms that can strip atmospheres from planets and bake their surfaces. For years, we wondered if Proxima b even had a chance. Now, there's a new narrative. This recent image, stitched together from spectral slices and hours of telescope exposure, shows something unexpected, a stable thermal profile across both hemispheres. And for a tidally locked planet, where one side always faces the star while the other remains in darkness, that's not what we expected. Instead of a scorched day side and a frozen dark side, we see a gradient. A slow shift from warmth to cold. Something is moving heat around. That something might be an atmosphere. If confirmed, it would be one of the biggest finds in exoplanet history. Because a protective atmosphere doesn't just regulate climate, it shields against radiation, supports pressure, and maybe, just maybe, holds water. Spectral traces suggest it could be there. Water vapor clinging to the planet's edge, possibly pooling in pockets, or hanging in cloud formations. There's no confirmed ocean, not yet. Webb can't resolve liquid surfaces at this range. But what it has seen is enough to fuel bold new theories. Some areas on the planet reflect thermal emissions differently, possibly because of mineral compositions or seasonal shifts. In short, this is a complex world. It's not dead. It's not flat. It might even have weather. And for a planet orbiting only 1/20th the distance that Earth orbits the Sun, that's nothing short of a miracle. This also forces us to rethink what we know about so-called hostile systems. For years, the assumption was simple. Red dwarf planets were long shots. Their stars were too unstable, their radiation too intense, and their gravitational pulls too extreme. But if Proxima b has an atmosphere, it means something is different. Either the planet regenerated its air after the early radiation storms, or it had defenses, maybe magnetic fields, maybe a denser initial layer, maybe something we haven't yet imagined. One thing's clear, it's holding up. At roughly 1.2 times the mass of Earth, Proxima b is well within the rocky zone, not a gas giant, not a mini Neptune. Just a big, rugged terrestrial planet orbiting its star once every 11 days. And that orbit? It places it squarely in the habitable zone, where temperatures could allow liquid water under the right conditions. That's what sparked so much interest back in 2016. But what we lacked was confirmation. now we're getting it. The Webb image confirms not only the shape and orbit, but the surface complexity. It has terrain variation. There are albedo differences, meaning some areas reflect more light than others, possibly from different rock types or even cloud layers. This isn't a smooth, dead surface. It has character, and possibly chemistry. Within minutes of the image's release, analysis labs around the globe jumped into action. Infrared spectral readings started pouring into climate simulators, and researchers began building models, not of some hypothetical exoplanet, but of this one, a real, observed world. The models show something unprecedented for a tidally locked body: energy redistribution. Air currents might be taking warmth from the bright side to the dark, equalizing extreme differences. That means temperatures across the twilight ring, known as the Terminator Zone, could be mild. Mild enough for chemistry, possibly even biology. Imagine an endless strip of dusk, a ring around the planet where the sun always hangs low on the horizon. It's not too hot, not too cold, just right. And if that strip contains pressure, warmth, and water, then it could contain life. We're still far from confirming biology, but even the possibility pushes the limits of our imagination. More than that, it shifts the scientific consensus. Because if a world like Proxima b can survive in the furnace of a red dwarf, it means many more worlds might be doing the same. Suddenly, our galaxy feels a little less lonely. Even the planet's crust tells a story. Webb's reading shows elements similar to Earth: silicates, perhaps feldspars, possibly hydrated minerals in tiny quantities. That suggests volcanic history, maybe even plate motion. At the very least, the planet has a solid surface with geologic variation. This isn't just a dot of light. It's a world. We've waited decades for this. From the moment we first imagined exoplanets, planets orbiting stars other than our sun, this was the kind of moment scientists dreamed about. Not just detection, not just a hint, but a full-spectrum, multi-layered visual confirmation. And it came from a telescope built to look backward in time, yet ended up gazing at a nearby future. As observatories pivot toward Proxima Centauri and research teams dissect every wavelength of data, the ripple effects are starting to reach beyond just astronomy departments. Climate scientists, planetary geologists, even philosophers are weighing in. This isn't just a node on a cosmic map. This is the first clear sign that Earth is not unique in its complexity. It proves that rocky, potentially life-supporting planets aren't a cosmic fluke. They're real, and they're within reach. Some scientists are even suggesting that the thermal gradients observed on Proxima b could be used as the basis for a new planetary classification system. Until now, exoplanets were categorized based on assumptions: mass, orbital distance, star type. But now we have real imaging data to show that those variables may not define habitability as rigidly as once believed. A world close to a volatile star, long thought to be uninhabitable, may in fact harbor stable zones where life could form or survive. There's another shift happening too. Governments and space agencies, traditionally focused on Mars, the Moon, and near-Earth exploration, are beginning to invest again in the deep future. It's subtle, but visible. Budget reallocations, research grants, strategic reviews of interstellar technology. The public, energized by Proxima b's reveal, is demanding more than theoretical progress. They want missions, timelines, answers. The echo of that first image is still growing. Every time it's shared, debated, or used as a wallpaper, it carries with it the same silent message: the universe is places like Earth. Not just gas giants or frozen exomoons or rogue wanderers in the dark, but warm, rocky planets orbiting stars, some with enough complexity to stir the imagination and trouble our certainties. Speculation, of course, follows close behind. Was that haze in the upper atmosphere just clouds? Or is there something in it, something more? Are those heat variances just surface texture, or could they hint at geothermal activity, tectonic motion, or even artificial energy emissions? Astronomers are trained to be skeptical, but they're also human. And seeing another world up close, even one without clear signs of life, triggers questions we've barely prepared for. Questions that force us to confront the scale of our ignorance. One of those questions. What if we're being seen too? If Proxima b has atmosphere, it may scatter light. That light might reflect our sun, our probes, or our own planetary missions. If we can image them, could something else image us? The idea isn't paranoia. It's math. The same math that predicted Proxima b before we ever saw it. The same probabilities that said habitable planets should exist in every second or third solar system we point our telescopes at. We aren't alone in the sense of uniqueness anymore. Even if Proxima b is lifeless, just wind and rock and silence, it is still proof of Earth-like planets orbiting sun-like stars. And that alone resets our place in the cosmic order. And maybe the most powerful thing about this discovery isn't the science or the speculation. Maybe it's the story that a machine, built by humans, launched into space by fire and calculation, stationed millions of miles from Earth, looked across 4 light years, and saw another world. It didn't guess. It didn't hope. It saw. We now live in a world where that's possible. And that means we're living in a time where anything is. So, what comes next? We keep looking. We build better telescopes. We imagine more sophisticated propulsion systems. We model climates not just on Earth, but on places we've never visited. We train AI to find patterns in star systems. We teach children to see Proxima b not as an alien world, but as the beginning of a path that might one day be walked. Maybe not by us. Maybe not soon, but eventually. Because this isn't just a scientific milestone. It's a human one. The universe just blinked back. And now that we've seen another world, truly seen it, we won't ever stop looking for the next. If you felt inspired, if this discovery stirred something in you, awe, wonder, curiosity, then help us keep the momentum going. Like the video, subscribe to the channel for more space updates, and drop your thoughts in the comments. What do you think we'll discover next? What would you ask if Proxima b could answer back? We're just getting started. Thanks for watching, and until next time, keep your eyes on the stars.